Hello everyone. So myself, Abhirama Subramaniam, a PhD student at IIT Jodhpur in VL2G lab, working under the supervision of Dr. Anand Mishra. So I'm excited to present a research titled Visual Text Matters, Improving Text KVQA with a Visual Text Entity Knowledge Aware Large Multimodal Assistant. I'll start with a brief description of the evaluation of VQA problem from its inception till the problem that we aim to solve in the current work. Earlier, VQA systems required models to perform simple visual recognition. Later, VQA systems required model to read the text present in the images on top of visual recognition. Text KVQA, which was introduced by Singh et al. In ICCV 2019, mandates the models to not only read but also reason over the external knowledge associated with the visual text present in the image on top of visual recognition. In this work, we revisit this challenging task of text KVQA and work it through the lens of recent advancements in multimodal AI in the form of large language or large multimodal models. So here, if you see the question such as which year this store was founded, right? So here in this case, so it was not clear which store was it. So to solve such task, we need to understand, we need to kind of read through the image and link it to its corresponding entity. We have to understand that it's 7-Eleven and then try to reason across the information of 7-Eleven to answer such questions. Over the past years, many large-scale language and vision models have been developed, demonstrating exceptional performance across various downstream vision language tasks, including but not limited to image captioning, visual question answering, visual grounding, among others, hence making them a de facto choice for vision language tasks such as text KVQA. However, despite their numerous advantages, they are not without drawbacks, notably the hallucinations. It can be observed that these LLMs or LMMs hallucinate, warranting the need for better visual text understanding and reasoning capabilities to solve text-aware knowledge-intensive tasks like text KVQA. Towards this end, we hypothesize that a perfect visual text entity linking is what all we need to solve text KVQA. Given an image, we aim to perform visual text entity linking and obtain the knowledge associated with the linked entity and use it as an additional information to answer the question. So visual text entity linking refers to the task of linking visual text present in the image to its corresponding entity in the knowledge base. In this example, our goal is to link the visual text to the entity of 7-Eleven. To this end, we first extract the visual text from the image using a visual recognition engine, basically a OCR engine. Specifically, we use DBNet for visual text detection and Parsec for visual text recognition. Both of these are open sourced recent state-of-the-art models on for text detection and text recognition respectively to extract the visual text present in the image. So once the visual text is extracted, we can leverage traditional text-based entity linkers such as direct match or normalized edit distance to rank and retrieve the correct entity among the entities in the knowledge base. So here in this example, text-based entity linkers retrieve entities that match with the words like coffee, 11, etc. So when such type of matches are being recorded, right, as these methods do not account for any visual information here, right? So they just try to get the word-based similarity, word matches, or edit distance-based match. So all the top entities will be similar to all the keywords here. So it will contain entities such as Costa Coffee, Starbucks Coffee, Cafe Coffee Day, along with 7-Eleven. So these entities are seeping in just because the word coffee is present in the extracted visual text. So further, for such naive text-based entity linkers, right? So they also suffer from more challenges. So one challenge we have seen is so it is a naive text-based entity linkers is they don't use any form of visual information surrounding cues, etc., to kind of link it to the correct entity, thereby the other unnecessary entities are seeping in, right? So apart from that, there are even more challenges such as abbreviated visual entity text. As you can see in the first example, RBS is a text present instead of Royal Bank of Scotland. So in the knowledge base, so the entity name is Royal Bank of Scotland, but however in the image it is RBS, it's a abbreviated form. So in such cases, the text-based entity linkers would fail. In the second image, it can be seen that visual text is highly stylized, right, making it harder for visual text recognition engines to extract the text. So the third example, which is an interesting case here, where the same visual text may refer to multiple entities. So in both the cases, you can see the HP text visual text is HP, but it might refer to Hindustan Petroleum or Helvet Packard. So it can be easily solved by humans, right? So it can be easily solved when you have the additional visual information, right? So these challenges make the naive text-based entity linkers struggle to link the correct entity. So to this end, we propose a principled method called VisTEL, an LMM-based architecture that leverages surrounded OCR text obtained using a specialized visual text recognition engine and the visual content within an image to perform highly accurate entity linking for the visual text entities. So, given an image, we first encode the visual content using VIT, then extract the visual text using the visual text recognition engine, and use the extracted text, right? So it is very similar to the problem. It is very similar to what we have seen in the earlier stage, right? So text-based entity linking. So you use the extracted visual text and you try to match it against the entities in the knowledge base and retrieve the top five or top K matched entities. So once you have the encoded image, visual text, and top K matched entities, you embed them using an LLM embedding module and you forward it to a large language model, in this case Llama 2, to generate the final entity 711. So it is basically trying to choose the correct entity from these top K matched entities. It is trying to refine or sort of re-rank them. So we have seen in some examples, it can also be seen that even though if the top K matched entities are do not contain the correct entity, these models, the large language model, is capable of generating the entity as well, the correct entity, even though it is not present in the top five, owing to the capabilities of these LMMs, right? So here is an overview of our proposed framework, KaLMA. So knowledge aware large multimodal assistant, so which leverages the entity linking capabilities of VisTEL to perform knowledge reasoning and generate accurate answers to the questions from TextKVQA. So here is a more detailed working of our KaLMA. So given a knowledge intensive question or an image, right? KaLMA first invokes VisTEL, right? To link the visual text entity present in the image. Once linked, we retrieve the associated knowledge of the linked entity and frame an instruction prompt as shown in the image and feed it to the LMM to generate the final answer along with its supporting fact, which acts as an evidence to generate an answer. So, the supporting fact also helps us to backtrack and address the hallucinations if they occur. Like, where is it failing? Is the entity linking has given the wrong answer or the mapping has given the wrong answer? So, exactly where this wrong answer is coming from. This will give us a sense of explainability and attribution ability to our model. So here I'm going to present briefly. I'll talk about the quantitative results on text KVQA. So we benchmarked few pre-LLM approaches like GPT-2, VILT, VLBART on text KVQA, and then we also benchmarked existing LMM approaches such as mPlugAll, InstaClip, Lava 1.5, and Mini GPT-4 V2, and this is the previous SOTA. And our model kind of beats substantially beats the existing SOTA by 23.3%. And also on the text entity linking performance. So we can see that direct entity match, and we can also the direct match based result we have shown, and we have also shown the result from edit distance based entity linking. And further, we also consider two recent multimodal approaches which are based on clip and blip, right? So these multimodal approaches they also consider the image, but however, they our VisTEL model still owing to its exceptional capabilities with the help of the specialized modules like DBNet and Parsec is able to outperform these multimodal approaches as well, apart from the text-only models. So limitations and future work. So see, we have also run the experiments in KaLMA, right, in an Oracle setting. So the Oracle setting assumes 100% perfect visual text entity linking. So where let us say given an image, we assume that we always know the ground entity, right? So here if you see when we assume 100% visual entity linking, the numbers are closer to 100. So this shows that there is still a lot of scope of improvement. The improvement can be from the visual recognition engine can be improved, or visual text entity linking itself can be improved, etc. So current limitations include, so our current proposed framework can handle only English based visual text and tries to link only English based visual text and cannot handle multilingual text for entities. And the further limitation is it cannot, we assume that there's only one entity present in the image and it fails if we have multiple entities present in the image, and we don't our proposed current framework doesn't handle the temporal entities, and we don't consider other visual cues such as logos, etc., which may also be helpful in visual text entity linking. So to conclude, we benchmarked pre-LLM and LMM methods on text KVQA, and we observed that they fall short, and we proposed a novel LMM formulation, KaLMA plus VisTEL, to solve text KVQA. We achieved 23.3% gain over SOTA and text KVQA, and the proposed VisTEL accurately links the visual text present in the images to the knowledge base, and proposed KaLMA combines the visual reasoning with the external knowledge, helping overcome hallucinations. So please feel free to visit our project page, and you can find code, etc. there. Yeah, thank you.